Continue on here, CFU 1.5. Again, taking a look at different ways we can graph quantitative data. Today, focusing on histograms as another method. Great way to kind of put it into categories. You'll see that stem plots and histograms are very similar in fashion. Stem plots, though, are nice because you get to see the individual scores. But boy, those histograms, we like them because they look much more pretty. So let's take a look at number one. A little off task here. So it says here, Shakespeare. The histogram below shows the distribution of lengths of words used in Shakespeare plays. Describe the shape and center and spread, okay, of this distribution. Okay, so the number of words used. So first thing I always like to do is kind of draw a curve over it. Kind of gives me an idea of what it started to look like. So the distribution of words used in Shakespeare's plays is, well, if we look here, is skewed to the right with a center around. So now we got to figure out, where do we think this center is about, okay? So we don't know the exact number of words that are used, so I'm just going to kind of estimate here. So we're at 15, that's a little bit more than 20. I'd say we're at about 45. At about 70, I'd say just a little bit more than 80. Now I'd probably say 90. These three, maybe a little bit over 105 or so. So I'm looking at a little bit more than 50 as the center, okay? Maybe around 55 or so. So I have 5 again, okay? This makes a total of, what did I say? That's 5, so that's at about 23. That puts me at about 45, putting my center somewhere right in around 4 words. Okay? Or it's not 4 words, my apologies. We're not talking about words, we're talking about letters. Good catch. So now, the smallest, now we want to talk about, okay, the range. Okay? So I'm going to note here the smallest word has 1 letter, and the largest word has 12 letters, making the range 11 letters. My guess is there's probably not an outlier here. I'm not even going to know, since it didn't even ask me. Just shape, center, spread. Got all 3 covered. We're done with that problem. All right, number 2, drive time. Professor Moore, who lives a few miles outside of college town, records the time it takes to drive to college each morning. Here are the times in minutes for 42 consecutive weekdays. Wow. Takes anywhere, it looks like, from a little more than 8 minutes, okay, all the way, well, I shouldn't be saying that because it's not in numerical order, which makes it a little more challenging because I see some 7 minutes, I even see something in the 6-minute range, and I see something that's a little bit more than that. So here it says, make a histogram of these drive times. Is the distribution roughly symmetric, clearly skewed, or neither? Are there any clear outliers? All right, so now what we have to decide is how to graph this. So again, with the histogram, the key thing is you got to decide what's going to be your bin width. So one of the things I'm going to look for is the lowest drive time. So here I see 6.75, and the highest drive time, so I see a 10.17. I'm just going to cruise and just see if, because sometimes this is fun, because I can even miss ones here or there. So now, frequency. Okay. And now, what I'm going to do is I'm going to put a little break because I'm not going to be starting at 0 with my histogram here. Now I'm going to start noting my bin width of drive times. So a histogram needs to have at least 5 or 6 bars. Okay, in my case, I'm probably going to go a little bit more than that. I'm going to count by half a minute, meaning I'm going to start at 6.5 minutes and go to 7, and then 7.5, and 8, and 8.5, and 9, and 9.5, and 10, and 10.5. All my times should fall in there. Hopefully, my frequency doesn't get too much higher. In this case, I just want to note how many drive times he noted, 42. So I don't know how high I really need to go, but I'm going to just kind of make a guess here and go up to about 10 to 15. So I'll just count by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Boy, I hope I don't go higher than 12. I was going to go to 15, but I did do my dashes very well. All right. So that's why if you make mistakes, sometimes a pencil can be helpful. Let's see if I get away with this one. So now I want to first start with drive times between 6.5 and 7 minutes, but not including 7 minutes, because remember the histogram falls to the right. So I think this was my only one that was in the 6s. So what I'm going to do is make a little bar here. I'm even going to put how many I had, 1. So now I want to see how many drive times are in the 7-minute ranges, but in the low 7 minutes. So one of the things I'm going to kind of do here is kind of underline all my 7-minute ones. Hopefully I get them all. And then I'm going to break them into their 2 groups here. I don't like it when I forget. So it looks like I have 2 that were 7.42, which would fall into that category. I don't think I have any more. Now I want to look at the ones that are greater than 7 minutes, or sorry, 7.5, but less than 8. It looks like I have 1, 2, 3, 4, 5, 6, 7, 8. I hope I got them all. Of course, if I make a mistake, I'll just erase and make the correction, because even I make mistakes. All right, so 8 to 8.5. So now I'm going to do all the ones that are less than 8.5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And that's all of them. I got 11 of them. So I'll draw that one up, and I like to write the numbers right above it. Keep on going now for the 8.5. So all the other 8s, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So one higher. Ooh, looks like Mr. Park's going to get away with it. So that's at 12. 9 to 9.5. So look at all these 9s. 1, 2, 3, 4, 5, 6. So he has a 6. And then anything in between. So I got 9.75. Only a 1. And I have that 1 in the 10. So I'm going to put 1. Whoops, didn't write the 6 there. So, I drew that a little high, but we're okay. One of the things that I like to do after I got my histogram is I just make sure I counted all 42 of them. So 1 plus 2 is 3, 11, 22, 34, 40, 1, 2. I got all the drive times. My histogram looks pretty good. Okay? So now, it asks, is the distribution roughly symmetric? Does it have any, is it clearly skewed? Neither. Are there any clear outliers? So I just want to make sure I answer that question. The distribution of drive times is roughly symmetric with no clear outliers. So again, the reason why I'm answering that, if I draw a little curve over this, okay, doesn't seem to be any clear tail in one direction or the other, right? And since there's no time frame where it took him like 20 minutes or he got there in 3 minutes, doesn't seem like there's any, clear outliers. All right, you can go on to page